And we are starting. Let me just see whether it got started. Looks like we are live, guys. Okay, guys. Started streaming for today. So the schedule for today is basically this session until 3 p.m. CET. Then a small break for lunch, and then the second stream from 3:30 until 6:30 p.m. CET as well. Then one bigger break here for training, workout, and then 3 more hours in the evening. So that's the plan for today. I want to go. Let's continue with the BUCC SH script, basically figuring out how the mining works in Laser. Let's see whether people got the notification. I see some viewers. Okay. Let's slowly get started. Let me just set up my, so I can see the live chat here. Okay, guys. Let's see where we stopped. So we were trying to do, this is the BUCC SH script. We've done extraction of the data, then we've done the embedding script, and then we wanted to test mining. And mining failed. That was where we stopped. Some GPU resource vector is not defined. Let's see what's up there. Okay, I think we first need to figure out how this embed script works when we pass these arguments. Let's see how that looks like. E-direction. Okay, this is the embedding directory. This is the file in the embedding directory. So let's go here. And then the part. Let's find it. With source language, encoder, and BPE codes. So we need to construct another launch JSON configuration basically for the embed script. We previously had this one. Let's now create another configuration. Let's call it embed BUCC SH. And let's basically start reconstructing the arguments. So again, we're trying to go through the mining script. The idea here is we have sentences in one language and in the other language. We're trying to first embed them. Then we're trying to basically find similarity scores and find for each point in the source language what are the nearest neighbors in the target language, and from those we source the actual parallel translation. We're trying to figure out what's the translation. Building the mined machine translation data set basically. Okay. So let's just see what's the definition of this one. So that's again the embedding script. Okay. And then this part is confusing me. So that looks like BUCC and then languages and then ends with train, which I don't see. What's up with that? Let's see, embed. Aha, there's probably just a prefix. There's probably just a prefix. Let's try and just print it out. Let's do that. Let's focus on, again, let's focus on a single language here. I'm going to comment out all of these 3 languages here. Just focus on French for now. And let's go down there. So we now have only French. Let's comment out the mining, and let's just echo the arguments. Echo all of these arguments and see how that looks like. So now let's call the script again. Okay, here are the arguments. Let's just reuse these. Copy. And let's create the script here. Let's see how the embed function looks like. So the first argument, so we first fetch the, okay, argument 2 is gonna be the first argument here. Okay, embed script. So encoder. Okay, let's print the encoder as well. Maybe a better thing to do would be to echo here. Let's just echo here. Just to echo here. No, sorry. Let's see how we can do this. Yeah, let me just echo the arguments. Encoder. Language. EP codes. And this. Instead of echoing here, it's better to echo there. Just enable one of these. Actually, let's enable both. And so now if we run this, what's up? Why didn't it run? So if the file does not exist, then if the file exists, then we echo this line, and then we call the actual embed.py. Okay. Let's see. Why are you not running? What's going on? Let's just echo something random here. And rerun it. Hi. Okay, that one is being executed. And then this one. Why are you not getting executed? The if statement should execute. Let's just maybe do it like this then. Okay, here it is. But why is it not being executed? That's weird. This part. Okay, got it. Only if it doesn't. Wait. If the size is 0, yeah, if the size is 0, then we do this. Because the size is not 0 of this file, we don't do this. That's why we're okay. So here are the arguments. Let's now just grab these arguments and build this launch JSON. So encoder. And then here is the encoder. And then we have token lang. Let's just remove all of this here. Token lang is gonna be, let's go with English because I don't speak French. So let's just do English. And then next up, BP codes. then for BP codes, let's copy again this. And then for output, let's copy the final line here, and that should be it. Let's maybe modify just to make it clear. So we'll be running, let's see, we'll be running the script is embed in the same, is embed.py in the same directory as buccash script. Let's see that. So here's the embed script, embed directory. Here is the buccash script, and embed.py is here. So because of that, let's just expand. Let's just do something like this. Let's copy the absolute path here. Just a second. So we need this whole thing here instead of this. And let's remove this. So we now have all absolute paths. And I'm just going to name this test. Okay, looking good. Let's now run the embed.py script. Okay, guys, I realized I didn't turn on the light. Let me just turn on the light quickly so you can see me better. Okay, that's better. Looking better. Let's go and run the script. Let's pick the embed buccash config there. Let's go here. And let's run this. So we're trying to figure out what's going to happen here. I'm not sure why. How can we run this without an input argument? That's the confusing part. So before we had an input file with sentences, output file, it's going to be a binary file, and then encoder and SPM model. Here, we just have encoder, BP codes, and we have the output. So where does the input come from? That's the weird part. Do we have any piping going on here? Let's see. So we extract, we call the embeds here, and then we call the mining. Okay, I guess it's just probably hard code some paths because it's meant to be used for buccash. I don't know. Not sure, to be honest. Let's leave this as it was, and let's run it again. So running it. How are you guys doing? Sunday, huh? Best way to go through Sunday, just some coding. Slowly waking up, yeah. Okay, why is it so slow? So input is not a required argument. Let's see what are the required ones. The required ones are the output and the encoder. Okay, that's the part, that's the reason why I want to run this. I want to understand every single step of the bucc sh script here. After we figure out how embed works with these arguments, then we can figure out how this mining function works, and then the bucc pi. Okay, here we are. Let's go here. So input is none, encoder. English is the token language, BP codes, SPM language, Hugging Face, buffer size. Okay, let's enter here. Nothing smart there. So encoder path. So let's load the encoder. Let's see how much memory it's occupying. Around 5 gigabytes on my VRAM, but the baseline was around 2, I think. So maybe around 3 gigabyte file. Okay, so let's see if token length different than this, and it is. Let's just see one thing. We did specify token length, right? We did specify. Yeah, okay. So that's the part here. Okay. So that because of that, we are entering here. We are creating a temporary directory, and we are calling this token object. What is this? Okay, let's figure out what's going on. If it's not a file, okay. gzip false, so that means we're doing just cat command. And then if romanize is true, it's false. Why is romanize false? Didn't we, if token language is EL, I'm not sure what EL is. If somebody can see the codes, what's EL? So let's see what's the logging statement here. Tokenizing in language English. Okay, so we're gonna run a command. Input file is empty, so that's the part that's confusing. What are we doing here? Here's the Perl command, the Perl script, the second Perl script. And what's the EL? Moses tokenizer. And then we're calling Python module Jiba. What is this? And then if language, okay. Macab. If language is Japanese. And then we dump that to this file here. Okay. Greek. Makes sense. Because Elinika, I think that's how you say Greek in Greek language. So let's just open quickly the output file here. So I'm navigating to the directory. Let's just see what happens after we run the command. Nothing. Wait, did we actually run it? Oh no, we did not. This is the part of the statement. Okay, let's just run it. So we are running it now. Okay, it's slow. I don't get it. What's the... This is gonna be empty, right? Chinese text segmentation. Built to be the best Python Chinese word segmentation module. Okay. Interesting. "600 issues. Looks legit. 10 years ago, the latest change." Nice. Why is this not working? What's going on? Again, let me just see one thing. The output, the final output will be under embed. And then here, BUCC 2018 French English train ENC, like encoded. French English train ENC English. Okay, so that there is 1.41 gigabytes of data in there. Okay. Is it running in the background, but there is just no logs? I assume that's what's going on. How can we double check that? Can we check some of the processes or something? Let's see. What's the command in Ubuntu? Hi Ken, welcome to the stream. Yeah, I'm still confused why this works. So we pass in, let me just double check the script again here. Embed function. Called embed with encoder, with token lang, with BP codes, and with output and with verbose, and that's it. Oh no, wait. Oh my god. Okay guys, that's the error we made. So it's actually printing the contents of this script and passing that as the input. That's the thing. Okay. Yeah, okay. We can just do it like this then. We can just pass as the input. So let's print this as well. And then we can just pass it as the input as opposed to via the standard input. Okay, so let's now rerun. Let's rerun this. Just a second. So let's open up this guy. And then let me navigate there. So let's run the the script again, and here is the input. So this is the actual input, right? So that means we have to grab one of these files here. So French English train txt.en. French English train txt.en, and then we pass this guy. Okay, to make the things a bit faster, Ken, by the way, you're not following the latest stream. You're still tracking me from the past. Let's do one quick thing. Let's just duplicate this file, and then on the copy, in order to just make this run faster, let's delete everything except for the first 3 lines, just for the test. So maybe a couple of lines here. I'm gonna copy these lines, then delete everything here, repaste that, and then grab the copy path here, and then just go and pass in as the input. We're going to pass in this. Okay, I think this looks legit. So we're trying to encode that piece of text. And we want to output it here. So like, let's maybe just add a prefix copy so that we don't mess up the Yeah, thanks, Brian. Okay. Let me just double check whether we maybe messed up so that we don't have any bugs later. Let me just see whether we messed up this enc file when we ran the script with empty input. Maybe, I doubt it. I doubt it because we didn't. Okay, I think we're fine. Let's just run this. Let's go to the embed script. Here is the embed script. Let's rerun it again. Okay. Now we're gonna figure out how this works. Now it should be fairly obvious. We basically have encoder, we have some sentences, and we embed them and store them to this output file. That should be all good. Although for some reason this script is using these other models, this bidirectional LSTM or whatnot. What's the issue here? I think we have wrong input argument. Let me just double check I'm calling the script correctly. So what's the input here? Did I get that right? Input. Maybe it's complaining. Let's just see one thing. Copy. This should be good. Okay. Let's rerun. Why are you so slow to run? What's up with my computer today? While we're waiting, let's just analyze the... Something's not okay with the speed. Let me try restarting the VS Code. Could it be that my count environment is too big? Come on. Okay, let's just analyze the code while it's doing its thing. Let's see what this token is doing. I can't even, oh my god, I can't even go to definition because it's so slow. Something's not okay. It might be struggling because all of these files are outputted here and they're bloating the environment. That might be the case. VS Code trying to index these big files or something. Okay, here it goes. Transferring the encoder. Okay, we are back here. Let's go to token. Let's go here. This should now execute fairly quickly. So we need, let's see where this is going to be outputted here. Let's just navigate there. Okay, and let's run this. Is it dynamic? Okay, encoded 4 sentences in 0 seconds and then it exited. Do we have any output here? We don't. Something's not alright here. It might be due to fast PPE. That did not work. We couldn't set it up yesterday or 2 days ago when we were installing the external tools. Let's see. So the copy file exists already. Huh. Interesting. It just didn't stop at the breakpoint, that's the thing. But it seems it worked. Weird. Let's just delete this guy. And let's rerun the script. Just add some breakpoints after here. And then let's rerun it. Okay. So. Okay, so as you can see, those are a couple of sentences that were just processed. How many lines do we have there? We should have like something like 4. Yeah. Okay. So now we set that as the input file, and we enter the BP codes, and then we call BP fast apply. Let's see what it does. Processing. Okay. Make sure this exists. And then we run. Tools external fast BP fast. This should not exist. Let's see. Tools external. Fast BP and then fast. Interesting. It actually exists. But something failed while we were building this program. Okay. And then, okay, so we do what? We call that program, and then we say apply BPE. Input file is here. BP codes are here. Let's see how this, what's this F codes? Laser models. Let's find the models directory. And then F codes. This guy. Okay, here's that file. So this is just the pairings and the frequencies or whatnot. And then the actual vocab is here. Okay, makes sense. Let's go back to the line where we stopped. So we passed the vocab, the F codes, the tokenized text, and the output. And then we are done. And then we just encode it. Okay, got it. It makes sense now. So I think we can continue. So let's go back to the, let's delete this copy file. Where is the embed directory? Source, tools external. Okay, it doesn't matter. Let's just go here. We are basically done with the embeddings. So we can just keep on iterating. So let's now try and test the mine function. Let's see how mine works. Once we are done with this, we can call the mine function. Let's just print out the arguments. Or actually, let's go to mine itself. See how it's called. Candidates. If the candidate does not exist, then we mine. Okay. Will it exist? If we just comment out this, and we just echo, something like this, and then I think we can run this now. We should skip, this should be cached, so we should skip both of these functions and just do the mining. Okay. About to mine, that looks good. Let me just remove the echo from here. Let's rerun it. Okay, processing, about to mine. Okay. So the hypotheses so far have been correct. Let's now figure out how mining works. So here is the mining function. Let's pass the arguments. Let's just directly run it ourselves, right? Let's see how that's gonna look like. So the first argument is this one. And then source lang, target lang. I think we can infer all of this easily from above. So let's just print this. I think we're good here. Let's just comment out this and let's rerun it. So here is the, okay, so that's the first part. Let's copy that. Let's create in launch JSON. We have mine by text. Is this the one? I think we've set it up yesterday, actually. Okay, I think we are good. We already have the arguments here. Albeit for German and English. Okay, let's just double check everything looks fine here. Source language, we have it. Target language, source embeddings. Source embeddings, are they here? Yes, and yes. And then we have unify mode and then mine. Retrieval max, margin ratio, K4, output candidates txt, and verbose GPU. Okay. Looks good to me. Let's now run it. Mine by text. Here is the script. Let's call it with mine bytexts, and let's just directly run it. So this is the first time we're running this one. Let's see how that looks like. Okay, here we are. Let's figure out what's going on in this script. Source. Loading texts. Open it up. Lines. Append. Einen weiteren Oscar erhielt er 2013 für seine Regiearbeit. Okay. That's just a German sentence. To make this, do we want to actually load the whole files or just reduce them to a couple of lines? I think we're good. Okay. What's going on in here? Sentences append. We just removed the last token. And then we keep on iterating here. The size of the directory is 1, so we increment this, and then we set this line to 1. Indices, and then we just append the line. Okay, we're just building some indices and sentences here. That's all good and fine. And we have how many? We have 400,000. And then a ton of sentences here. Okay. So that's the German corpus. And we now repeat the same for English. I see my OBS is struggling to connect. Do you guys still hear me? Hopefully you can hear me. Let's continue. So here is the definition of some function here, unique embeddings. Let's see what it does. Yes, awesome. Awesome. Thanks, guys. Embed load. Source embeddings are here. That's what we computed in the previous step. And then dimension, verbose. Okay, so embed load. So we're going to load the embedding file for source language, for German. So we basically just grab that file, we load, we resize, and we expect it to be exactly the same number of sentences as before. So 4024 dimensions there. Sounds good. And that corresponds exactly to the number of lines in German. So that looks good. And then we call the function unique embeddings. Okay, so is that some sort of deduplication that they do in the embedding space as opposed to just in the sentence, in the text space? Let's see what it does. So we pass in the source indices, we pass in the embeddings, and we say verbose true. Let's see what it does here. So enumerate, it's going to be just identity mapping as far as I can tell here. 0011, yep, that's identity mapping. And then we call, okay, then we say, aha, interesting. So we just filter out some 1,000 sentences, but there is no logic. It's just that what, for some reason, aha, okay, got it. Because we had only 412,909 unique sentences back when we were calling this. How do you compute unique ones? Aha, and unique. So shouldn't the number of sentences be the same? Then wait. Aha, got it. Makes sense. So the sentences is actually 412,000 in length. Okay, so let's go here. All good there. So if we were to actually, let me see. No, we don't have sentences available here. It doesn't matter. I'm just rambling. So we now normalize all of the embeddings, because I assume that if we just grab a single vector, and if we do the norm, how can we do norm? MP, is it norm? Oops. MP norm or something. Let's just see how we do that in NumPy. NumPy calculate vector norm. You can see here it's not 1, so we can now normalize it. Let's see what this does. This function here, okay, basically just calls some, this is FIS package, by the way, from Facebook as well. So if we normalize this, and if we rerun in expectation, we get 1, and exactly we get 1, as you can see here. Let me know if you guys can see the terminal, but like here is the number 1 here for the norm. Okay, that looks good. Oops, let me just zoom in a bit. And then we do the same for target embeddings. We load the target embeddings, so that's for English language. It's glitching for some reason. My VS Code is slow. I'm fairly sure it's because it's bloated with files in the file system. It's trying to index in parallel, and then it's slowing down the whole execution. Come on. Why are you so slow? It's frozen. Let's see what's going on here. Retrieval. We can just analyze it like this, but while we're waiting for that to happen. Retrieval. What's the argument there? Retrieval, we passed max. Okay, so we're using max retrieval. So that means if it's different than backward, we enter here, and we're going to do some k and n. And same here, and then some margin function. Okay, so this is basically implementing the logic that later FIs will just do for us. I think this is just more of a pedagogical script, more than anything else. Let's see what KNN does. Okay, finally. Come on. Okay, I'm just gonna kill the program and see what's going on here. Just fucking stop. I can't even kill it. Wait, I'm gonna kill it literally manually. If you guys have any better way to kill a program in Ubuntu, just let me know. Trying to kill VS Code basically at this point. Where is VS Code? Is it just code? This is a mess. Wait. Did that even kill it? Maybe it's just running in the background still. Hopefully not. Sorry about this, guys. Technical issues. Not sure what's going on. Why is it so slow? Monitor. Memory is fine. I have literally 64 gigabytes of memory. Like, I have a more than powerful machine to handle this. Okay, I found the command. It's just this kill all code. Yes. Just kill it. Kill the motherfucker. Okay. Good. Let me see how big my directory is. Okay, here we are. Perform for and source against target. Okay, so case set to 4. Using a GPU. And then we call the KNN. Let's see what it does. KNN GPU or CPU. So here we are. Let's see what's going on. And we allocate, what is this, like 5 gigabytes of VRAM or whatnot. Batch size, fairly big batch size. X shape, what is X shape? Let's see what's the dimensionality of this one. Shape, that's the number of sentences, and then 4. Okay. So for each sentence, we basically find 4 nearest neighbors. And this is going to hold the actual scores, and the IND is going to hold the indices of the target sentences, I assume. So now let's go through the X from, and then X2. Is batch size that big? Yeah, it's 1 million. Okay, so we basically do everything in a single pass because we have much more memory than the size here. Okay. Y from 0. Y2 is also going to be max. Okay, that's good. And then we call FICE. Okay, so here is FICE. So now the thing is, okay, I now realize why this is not working, guys. Because we installed the CPU version and we are now trying to call KNN GPU. So it's going to fail probably over the next couple of lines. Let's see. So probably already here, it's going to fail. And yeah, exactly. Okay. GPU resources vector is not defined. Okay. Let's go and install let's go and install the files for GPU. That's the issue here. GPU, CPU only, GPU plus CPU version. Okay. Let's do this. For Vice GPU, the NVIDIA channel is required for CUDA Toolkit 11.4, which is not published in the main. Let's try and run this. I should have installed the GPU version straight ahead. So this is where it was failing. Standard GPU resources. There is no definition unless we install the GPU version, which I'm currently installing. Let me see what's going on with my internet connection. Internet speed test. Okay, I'm on optic fiber, by the way, so I should be good with my internet. 400 megabytes per second. Nice. Okay, did we install it or did it fail? Conflicts. A ton of conflicts. We can just use the CPU version. We can just omit the GPU flag and then it's gonna work. Okay. Yeah, that's a good point. You don't have a GPU. Colab is an option, but you'll struggle with setting up the environment. Maybe you can just follow this part. You can also run on CPU only. None of this is too intensive yet. I think let's just, for the sake of this script, we can ignore the GPU for now and let's run it on CPU. Let's see how fast it's gonna be. That might be super slow. Or no, it's not going to be slow because it's just comparing vectors. It's not going to be running any inference or anything. So I just removed the GPU flag here, and I'm going to rerun this. So let's rerun the code. That's the easy way to fix this issue as a workaround. If you buy a GPU, well, it depends. I'm not sure what's the best offer. It might depend where you live. And for example, I found the latest GPU I bought for only 750 euros, brand new, which is super cheap, and so I had to buy it. 4090, I think it also occupies like 4 slots, so that's something to take into consideration if you're ever considering going the basically two GPUs in your system. You have to consider the layout of your case and stuff. Okay, let's go through it again. So now I assume we're gonna enter the CPU route. Okay, yes we are. And then we basically just add Y, and then we search. So let me see. So index flat, Y shape. Okay, it's like that. And then we just do search, and we will get the results hopefully very soon. Although there is a lot of comparisons to be done there. Maybe it might take a while. Not sure. We can always reduce the file sizes because we're just testing here. So I have RTX 3090 already. I'm not gonna buy any GPU for now. I might build a server, so for that I might be building I might need a different setup. I'll have to buy a motherboard and everything else because I can't squeeze in more than 2 GPUs in my current rig. Okay, so after we have this KNN, then we do the mean, and then we do the same thing for forward. And then we do margin functions. Okay, so we find for each of the source sentences, we find the neighbors in the target, and for each of the target, we find the neighbors in the source. That's the thing. That's why we have these two here. By the way, I have a video series where I built my current setup. It's called Digital Dragon. That's how I called it. Let me take a picture and send you on Discord. You can check it out. Let me send you the. Maybe like this, although currently not as nicely looking because I have RGB lightings. It's just that on Ubuntu, it's harder to set up the lights than on Windows. Check it out in the Meta NLLB replication channel. encoding, UTF-8. I'm just analyzing while it's running. I already see the logic here. So we're going to do the ratio. That means we're going to have this lambda function here. Then we open the file here. Candidates. Okay, that's going to be the candidate file. And then if you're mode search, I think we're not mode search. We're mode mine. We're mining. We're not searching. So that means we can ignore this line. We can ignore this line, and we are here. So we'll be mining for parallel data. Score candidates. And then we have forward scores and backward scores. And then we find the best ones. Okay, this is cool. To actually mine for data, we'll definitely need the GPUs. This is highly parallel, and GPUs are the best setup for that. Embarrassingly parallel, probably. Score candidates. We can enter here later. Okay, guys, I think what we should do here is... Wait, is this even running anymore? I think it's... Okay, there was a fatal error. That's what's happening. I didn't even see that. Okay, there is an Intel MKL error. Undefined symbol. MKL sparse optimized BSR TRSMI8. Cannot load. Let's search for this error. So we have issues both with the CPU version as well as with the GPU version of reinstall from conda 4 channel to resolve this. Let's see what's going on. So we're struggling with files for those of you who just joined. Trying to see what's the issue. We are hitting some MKL error. Cannot load libmkldef.so1. I think they mentioned something install. They mentioned something here directly, some issues with MKL already, I think. Okay, yeah, I'm not on an Intel platform, I have an AMD processor. So I'm hitting this issue myself. Okay, let's see. Let's uninstall MKL. And let's now install it again, but separately. Where applicable. Well, this is Intel library. Wait, we don't even need this. Can we run this on AMD at all? If anybody has a clue, let me know in the comments. Let's see maybe whether somebody mentioned AMD. Let's uninstall CPU as well. Okay. Let's try and run this. Will this work? This might just work, but I'm not sure how to. Why is it installing MKL if I just need to run it on AMD? No idea. How are you guys doing? Enjoying the Sunday? Okay, let's see whether this worked. Or it messed up my environment completely. Okay, done. Okay. Let's try and rerun this. Again, some import error. Why is it mentioning Intel? I don't care about Intel. I'm just running pip install mkl, and maybe it requires it even if we are not running on Intel. I'm not sure. I hate having to deal with the dependencies, but that's a part of the job. A big part, unfortunately. Okay. Let's see what's going on now. Did we install Pi's GPU or not? What's going on? Okay, just trying to uninstall and install it again. Let's see what's going on here. We could go the Docker route, but we're still gonna hit issues because I saw it's not up, like, there's some issues with Docker as well. Okay, let's just try again. If it's not working, then I don't know what to do here. Let's see. Yeah, Brian, I read that. But it's not applicable, right? Because I'm running on AMD CPU, so I guess that hopefully constitutes a not applicable. Maybe let's try. I'm not sure what this command here does. Is that NVIDIA Splash library? Basic linear algebra or whatnot? This is just such a pain. pull everything and see what's going on. So we have here, let's kind of start logging the errors. We've done this. Okay, this is when we install without the MKL. Let's start. Let me do the following thing. Let me try and deinstall it again. Let's uninstall it. Yes, just uninstall it. Let's install the whole thing again. Let's see is there any different error when we do this? Yeah, just install everything. Okay, done. So what's the error here? Okay, so the error here is when we try now, at least we can now run it, but this is gonna fail because it enters. Why are you entering the CPU? This doesn't make any sense. And it's gonna fail now, right? Let's see whether it fails. Maybe at least it works because when you install the FI's GPU, it should work on the CPU as well. It's a superset of the FI's for CPU. So maybe it works just slower because it's being run on the CPU. That would be an acceptable trade-off for now, just to get this example working, and then later we can figure out the issue with the environment. If that makes sense. This is just such a pain. Yeah, Brian, I basically tried all of alternatives. I tried without MKL, I tried with. I'm just trying to brute force it at this point, to be honest. Just to see whether it works. It seems it's working, by the way. Let me see my CPU, system monitor, resources. It seems we are running on the CPU. Yeah, this looks like it's working, man. Let's run on smaller files. This is too big. These two guys are too big. We can have test files, because this is too slow. Okay, let's just quit this. Let's do the following. Let's just have a test file here and here. I'm going to create a couple of lines only. I don't want to waste time having to wait for compute. So let's go to embed. Embed, and then we're looking for CCDE train. Okay, here it is. Train txt. Okay, so we want to now do the following. Let's just copy this guy. And let's reduce it to only a couple of lines, and then do the same thing for English. Maybe instead of like keep 1,000 lines or something. So let's call this guy test. Okay, and things are terribly slow for some reason. I'm just annoyed. Nothing is working. VS Code is just glitching completely. Okay, test. Let's go and keep the first 1,000 sentences, because we ultimately do have to allow it to mine for some meaningful data. So let's just do this. So we're gonna have maybe these first ones. Let's copy paste this. So let's delete everything here and just keep the first 1,000 lines. And then let's repeat the same thing for English. So we go here, train txt English. Let's copy paste this one. Let's rename it to test. And let's keep the first. Can you not show anything again? Please don't show this again. It's annoying. Okay, let's copy paste all of this. Delete, copy. Okay, we have our test files. So now that we have our test files, we have to quickly rerun the embed, and then we end up with test files here. So test and test. So to get those, we have to quickly rerun the embeds again. And let me do that. So let's go to the embed file. So let's go to embed.py and let's set up JSON here such that we run those here. So we said German, English, like this, and then we grab the test one, and then we do the computation there. Token lang, what should be the token language? I guess German here. And the output is going to be test German. Okay, something like this. So again, we have this file. Let's double check that's the right one. Okay, looking good. That's the German version. German. And then this guy should already be down there. Okay. I think this is all right. So now let's run embed with this guy. Let's run embed with this. Okay. There is one learning. Never ever keep the data in the same directory that VS Code is opening up the project. I might have to change all of the data paths just to make sure this is not terribly slow. This is slowing me down. I don't like this. Okay, here we are. Encoded. We should now see the test file here encoded. And indeed, here it is. Okay, let's now run the same thing just for English. So English here, and test DEEN English here as well. And let's rerun it again. And after we've done that, then we can finally run the mining script on CPU and expect the runtime not to be terribly long. Ideally, we'll soon go through the whole shell script and understand everything. There is some issue here. I didn't pass good arguments. Let's see why. This should exist, right? This should exist. Here it is. This guy does exist. Okay. And then English, that's fine. And then, okay, that looks good. So why are you then complaining? Oh, I think I ran a wrong file, this one. Okay, yes. Nice, guys. Whew. Okay, let's now go to mine. Let's change this to mine. And let's rerun this. Let's see whether we get only 1,000 embeddings now. Okay. I'm expecting X shape to be 1,000 something. Okay, that's good. Let's go. Y should be around 1,015. And it is. That's good. And finally, we can do the KNN. So we go here, we enter the CPU thingy. This should be much faster, and it is. Okay, awesome, guys. Awesome. This is shape 1005, all good there. This worked. Nice. And then we do, so let's see what we do. So we get, so what this does is for each of the source German sentences, we found 4 candidates. We found the similarity scores. So let's, for example, let me show you one thing. If we go, let me zoom in for you guys so you can see this. So if we go here and if we grab the first candidates, let's see, why don't we see the output? What? Just a second, something is weird. It's not printing anything, that's weird. Okay, let's just step over here. I think it's just glitching. Again, VS Code glitching. I mean, I literally have the best AMD processor, 64 gigabytes of RAM, 2 GPUs, RTX 3090, as SSD with 1 terabyte, like all best specs, and VS Code can still not deal with a bit more files. Why? And I'm not changing them even. Come on, bro, you can do it. Come on. Okay, you can see now, finally, all of the results. Let me rerun it again for you. So here, let's grab the first one. So you can see the scores, right? And then this is the best candidate, this one here. And the indices tell us where did we found those candidates in the target corpus. Okay, and then we just repeat the whole same procedure here. We perform KNN target against source. We find the values, and then I'm not sure why we do the mean. Why are we doing mean? Why are we reducing the candidate scores? What's the... Oh yeah, okay, I know, because of the... That's the score, the ultimate score they'll be using to find the candidates. I remember that's kind of a confusing bit from the paper. Let me know if you're confused there, or if you're following this part. I can maybe open up paper quickly and show you the formula. Ultimately, now we want to build candidates output, and because we are running here, let's see what happens. Where do we actually create that candidates file? Probably here in the same directory. If we open up this, will we find the candidates there? Nope. Huh, interesting. So mining for parallel data. Let's now go. So we have the embeddings, we have the indices, we have the mean for both directions, the margin function, which is going to be the ratio, and that's it. Let's enter here. So we're scoring the source candidates. Okay. Candidate indices is of shape. Okay. So we're finding 1005 candidates for German sentences. We initialize it with zeros. And then for each of the candidates, we'll find the index, and then we compute the score like this. So we need the embeddings for the ith source, kth target, and then we need these guys. These are the means plus the margin function to compute the score. And here is how we compute the score. We do so it's not only cosine similarity, and this is cosine because we normalized the vectors. The norm is 1, and then we do this weird average of the scores and then a ratio to compute the final score. And then we end up with all of the scores there, and now we're gonna do argmax, I assume. So once we do that for both sides, then we do, as you can see here, we do argmax. Got it. So we find, so this is going to contain the best indices. Forward, backward, and then what's threshold? I'm not sure. Okay, threshold is set to 0 here. So if it's maxed, and we're almost done with understanding the logic here. Backward best, we do a range. We concatenate that with what? With forward best across axis 1. And that does what? We end up with indices of shape 2018 2. Interesting. Aha. Okay. Scores. Where do we write to F out? Okay, here we print to F out. What's the syntax? What is minus? What is minus scores? Weird. Let me just print one of the fields here. Wait. Scores shape is like this. Okay, no, scores shape is actually, aha. So we've already done the max. And if it's not seen, these are just sets, then we add them. And if the score is bigger than threshold, and threshold is 0, so we just, here we are going to be adding everything. Okay, got it. I don't understand every single detail, but it doesn't matter for now. So we wrote these alignments to assign to candidates txt, and we got our basically mapping between the source and the target corpus. Let's now see, where is that file stored? Where did we save the candidates txt file? So I ran this directly. I'm expecting it to be somewhere here, but I didn't see it before. What's up here? Let's just do it like this. Under laser, file, okay, so it's directly in the root. Here it is. So here, guys, you can see what happened here. Ultimately, if we had higher threshold, we'd have higher accuracy, better coupling. Let's see whether some of these translations make sense whatsoever. Okay. Die Zahl letzterer ging allein in Frankreich zeitweise in die Zehntausende. By September 2007, the number of plaintiffs in the case reached 10,000. Okay, kind of similar because it mentions 10,000, but let's see the second sentence. Am 22. November 2005 wurde Angela Merkel mit 397 der 611 gültigen Stimmen, Gegenstimmen, bla bla bla. 3 abstained. Again, this is similar in spirit, but not quite the right translation. Alles in allem erzielt jeder Dollar, der für Familienplanungsprogramme ausgegeben wird, sage und schreibe $120 an Nutzen. Oftmals leben mehrere Volksgruppen gemischt innerhalb von Siedlungsgebieten, deren Einwohnerzahlen nur geschätzt werden könnten. Similar but not perfect, and the reason is this is just a dumb example, right? Like we can't obviously, I only had 1,000 sentences from one corpus and 1,000 from another one, so that means I dismissed most of the sentences in both source and target corpuses, but it doesn't matter. Okay, guys, this now works. The logic works. The outcome is not really super insightful. Let's go back to our original script, which is the bucc shell script. Buck shell. I'm gonna call it buck. Easier to pronounce. Okay. So that was the mining. And then after we've mined, what we do now is we call the final this buckpy script. And then we embed again something, and we mine again, and then we call buck again. And then later here, we call mine again. but we know the logic, right? So let's now just focus on figuring out how to run the bug script to understand what's going on here. What was the name of the candidates here? Output candidate. Okay, blah blah blah. TSV. Okay, so it's TSV, whereas we named it TXT. Okay, fair enough. Let's just print all of the arguments here. Let's print this guy. Let's print this guy. And then this. And then let's print this. And then let's print this. And then let's finally print this long one. Okay. And let's run this. So, okay, we gotta go to tasks, to buck, and then we have to run the bash. No, let's run the. Okay, I'm just gonna run it manually. Okay, here is the. Here are the input arguments that we need to just now pass directly into the script. So let's create another config. Let me just zoom out a little bit here, easier to navigate. Embed, mine. Let's create yet another one. One more config. Okay, so Python, we are running now the buck.py. This is for buck.py arguments, and let's just now grab these. So source language. We're going to be using the running example I'm using is German to English. So let's use that. So let's just do the following. Let me delete this guy. Let me delete everything here. And let's just start from scratch. So source. So once I've set up this, later it's going to be so much easier to debug stuff. So source language for us is German, Deutsch, and then there is the target language, which is English. And then there is this buck text argument, and the answer there is this. So we're just going to change everything to German here. And also we are going to be using our test versions. So those are the smaller files, if you remember. I just basically left only 1,000 sentences. Okay, looking good. That's the buck texts, and then there is the buck IDs. Let's paste that one here. And then buck IDs is basically the same thing as the previous argument. We just changed the suffix. We can just paste this here, and then we change the suffix from txt to ID. I'm not sure whether we have this file. Okay, we'll probably just have to create it. We'll have to create the ID file as well. We're just gonna keep the same lines as let me just do that immediately. So let's go to here. Let's go here. Let's find the corresponding files. So German, English, train. We're looking for these guys, right? Train, TEN, train. Okay. And so here are the sentences, and we only kept, for German, we kept the first 1005 sentences. So let's accordingly modify this one so that we only keep the first 1005. Okay. Oops, no, that's not okay. Because remember, we want to modify this, but not in place. So let's copy paste that one, and let's copy paste the English one as well, and then just modify those. Okay. And while I'm doing that, let's grab the English one and copy paste it. Okay. And so for the German version, we are keeping the first 1005 lines. So these guys. Let's copy that. Let's remove everything and just leave those. Looking good. And finally, let's rename it. Let's just rename that to test, and then remove the copy here. And here, let's see what we've done there. So for English, we kept 1014. So let's go to 1014. Here are the 1014 sentences. These codes, and then we keep those, and then we just rename this, and looking good. Okay guys, we are good. Let's go back now to lawn.json and let's continue. So we add buck IDs. We now need the candidates. The candidates go here. And we have to copy the candidates are looking like this. And for that, we'll need to move our candidates file and rename it. Okay, looking good. And we just have to copy our candidates TSV from the root. So let's do the following. Let me just open up the directory. Let's go here and let's find the candidates file. Here it is. Let's cut that one. Let's go to tasks, buck, embed. And let's paste it here. I'm so bad with Ubuntu. Like it's not. How do I even paste now here? Candidates. Okay. Candidates. Let's open up that file. Looking good. Let's just rename it to this. And we should be go. We should be good to go. Let me just find why is it complaining about such a file already existing. Really? Where? That file already exists, and let's make it 2. Aha. So here's the previous one, but it's empty, so I'm gonna just delete this one. Bro, can you just go? Delete. Error while moving files to trash. No such files or directory. Then skip it. Whatever, I'm just gonna name this one like this. Add suffix 2. We're good there, and then let's do the gold. And then okay, and finally verbose. That's it. Let's just make sure to expand this. Bug 2018, this should be German to English training gold. Where is this guy? It's here. So instead of embed, we just need to copy paste all of this. Instead of embed, we go here. And this one should contain the gold versions. DEEN training gold. Okay. Now the issue with this one will be also, yeah, let's just keep this one, but like the thing is we reduced the number of sentences, so this we might need to reduce this file as well. Okay, for now let's just run the bug py file. Here it is. This is probably just doing the evaluation, that's it. Tools for bug text by text mining. Okay, that's the main file. Bug optimize. Let's see how this looks like. Looks like a short file. We're almost done. So let's pick the bugpy config and let's run it. Okay. Laser tools for bug by text mining. Assert that gold is specified and threshold is bigger than 1. Okay. Propose reading sentences and IDs, all good there. Store slang German. We open up this one and we read the sentences, and we have 1005. And then we do the same for IDs, and we have 1005. And then for sentences, we just map sentence to ID, and then we repeat the same for target, and we are ready. So we are reading the candidates file. We open up the candidates file. Here is the score. Here is the source. Here is the target. If you remember, we were reading the sentences and comparing them manually before. So score, source, target, find the ID, find the ID. What's the max? And then we say that the candidate score for this pair is this big. Okay, got it. And then once we create that, (603) in length. Why? Why do we expect them to be the same length? Let's see what it does. Might be some optimization detail that matters. Okay, maybe we can disable it. Okay, let's try and rerun this. Let's see what's going on here. So again, we are just now basically evaluating whether the mined data set makes sense, where the arbitrary is basically the gold data set, the gold. We have gold labels for which sentence from the source language should be coupled to which sentence from the target language. So let me run this. Let's put a couple of breakpoints here. If you just came here, I'm running the file, but like VS Code is super slow for some reason. I'm trying to figure out why. Probably because too many files. I tried killing it as well, but it did not work. Still slow. Maybe I need to just restart Ubuntu. Okay, here we are. Let's just skip all of this. Let's skip all of this because we've done that. And finally we have this. I'm not sure why we have 600 only, because this, how many, what's the length of this guy? Length here, 1005. length here is what? 1012. And then, okay, it might be that there are some duplicates, and then because this is just a dictionary, it's removing them. Anyhow, it was just a dummy test because we cropped the original data sets to make it faster. Gold, let's open up the gold. So it contains the correct mapping between the source and the target monolingual datasets. And now let's find the threshold using buck optimize. Okay, let's see what it does. Got it. Sorts them according to the score, right? And then finds the length. Threshold will probably be 0. Yeah, it's going to be 0 here. And then intersection will probably have 0 as well. Yeah, okay. So precision is 0. Terrible result. And then only if the threshold is above 0, we would have printed something, and then buck extract would basically do the following. Open the file name. Oh, what's the third argument here? Output. We didn't even specify the output because it would go here. Okay. Let's see what's going on. Candidate scores. We would just basically go through the results, append, and then write, and then close. Okay. So basically, we would be appending these guys from this, and this is, okay. Yeah, that's how we create the final mine data set. So this was, yeah, I think I completely understand this example now. We don't even have to run the buck bash script because it's going to be super slow. Again, still using the CPU version of ICE. I'm going to stop this now. And let's go back to the buck shell script. Let's just skim it because we don't have to really rerun it again. Mining, so it's going to do extraction, embedding, mining, and then create the data set, the mine data set. And then we do the same for test. And then, okay, so it basically train and test. And finally, bonus extract by text with English alignments. I'm not sure what that means. Using a conservative threshold of 1.1. All the data is supposed to be already tokenized. Okay. Huh. So we go through the languages. If the source language is different from English, Let me just figure out what this logical statement does in Bash. Yeah, I'm interested about the A in between. This condition is a logical operator that stands for AND. Okay, this is AND. So this different, and this different, and this. Okay. Both source and target are different from English, and they're also not equal to each other. So we are looking for non-English directions. Okay, that makes sense. And in that case, we run the mining just to see the, why is it called English alignment then? Not sure. Anyhow, guys, I think this was great. Let me just open up the Notion. We're making some progress here. Okay. Still not working on the GPU, but it is working on the CPU. Okay. We did analyze all of these. So now let's see what else. I want to get a bit comfortable with the code base, so that's why I'm doing this. I'm just taking some time to get comfortable with laser code base, and that's why we are going through these examples. Let me now just collapse a couple of these directories. A ton of data. I'm gonna now delete all of this because I think that's what's causing the slowdowns. I'm gonna delete all of this. And then I'm gonna also delete the CSVs and the logs here. Just delete all of this, move to trash, yes. And we should be better now. Okay, so that was the buck example. We can now go through maybe a couple of other ones. Let's quickly skim maybe through the whole code base just to see what's up. What do we have going on here? Utils. Let's just go through the code base and see. Get some level of the get some understanding of the high level structure, and then we can maybe run a couple more examples if that makes sense. Let me just close everything here so that we have it nice and wide. Almost 2 more hours to go until the end of this stream, unless my camera dies before that. Then we'll just quickly stop, and I'm gonna change the battery, and then we can continue. Okay. Sentence split. Language mapping, dictionary. Supported tokenization algorithms. Mapping between ISO 3 and 2. Indic languages, Gs, split Gs. Oh my god, look at these tokens. Scary. Test sentence. split Burmese. Indic normalizer factory. Okay, guys. Allow send token. What's this? Just see what this is, but this is just some obviously sentence splitting for various different languages. And you have to have installed packages, particular packages. Okay, basically depending on the language, we return a particular language specific splitter. That's how it looks like. Remove non-printing characters. Okay. Demojizer. Removing emojis, I assume. Cleaner splitter. Get sentence candidate modifiers. Okay. Split clean. For line in standard input, we read from the console. We do right stripping of the new lines. And then we split on the tabs. Reach sentence from paragraph. What does this do? Okay, just some manipulation on the symbol level. We can ignore all of this. So those are the utils. And then we have task here, source, a couple of data sets here, NLLB 200, Tatuba, Docker. Maybe we'll need this, so let's just skim what's going on in Docker directory. Do you guys hear me well, by the way? Am I too quiet, too loud, or too silent? What's the word? HTML. This is just, I guess, some simple web app or whatnot with a couple of routes. The root route, the vectorized route will do something. Okay, so this is basically, okay, got it. Basically, this allows you to create a server and then just submit probably some corpuses for mining or whatnot. Let's confirm that that's the case. Sentence encoder. Token encode. Okay, no, this is the embedding endpoint. Cool. Nice. From file, resize, and then we return embedding list and content. What's content? Content is the original. Content is the original submitted information, I assume. Yeah, so that's the request, the actual request from the user. Okay, makes sense. So that's the app, and they run that on port 80, and that's it. And then there is a decode file. There is the Docker image, Docker file. installing some tools here, copying requirements, cloning laser, installing the models, installing VICE, the vector database, external tools, copying some files, echoing, run the embed script, run the decode script, expose, copy, and just run it. Okay. This is just like a dummy Docker, just an example, I guess, of what you can do with this. To help you with the settings of an environment, here are the steps to follow. Execute it. Okay, a REST server on top of the embed task is under development. To run it, you'll have to expose a local port. Okay, and here's just an example of how you can use this. Example URL and example request, where you ask, hey, how are you? I'm okay, and you? And then you send requests to that URL where you already have the Docker app running. Okay. Laser encoders, that's something that I've downloaded. Models as well. NLLB. Okay, that's the script I ran. That was the README here. Let's just skim to see whether I missed something before. New laser encoders referred to as laser 3. Please run the download. We've done that before. And then you can embed using those laser modules. Okay. Let's skim through sources, and then what I would love to do in this stream until the end is to start playing with a couple more tasks. Just get comfortable with the code base here. And then we can already start preparing a strategy. Which languages we want to support. Do we want to start with 202 really, or maybe just focus on a subset and then train some dense checkpoints? I think that would be a good start would be to focus only on a couple of languages and basically train a small checkpoint just to have everything working end to end. And then we can later start expanding the scope. We can probably do that in a week or two. Okay, let's see what's going on here. A couple of these files. We can start maybe here. This is this metric for multilingual similarity error rate. XSIM. Okay, we don't really need to care about this for now. XSIM, similarity search. What does this do? Encode load. we just encode, and then we load the embeddings using index create, and then we call index search multiple and index print confusion matrix. All of these come from Feist, I assume. Index create and all of these guys from indexing file. Okay, so those are up there. Okay, we're gonna check out those very soon. Sentence classifier. Okay. Load data, load text, tensor dataset, data loader. Net. Modules append. This is just building some network, and then test corpus. We run some inference, predictions. Okay, that's the classification part, I guess. How many of the examples are guessed correctly? Test corpus. We'll probably see how this one is used in one of the examples later. Okay, we actually have some training here going on. Going through the epochs, train loader. And then we basically evaluate on the test corpus. And we train on train loader, which was base directory. Is there any default reasonable value? No, we have to specify some data set. Okay. Okay, we're gonna check out that later. Playground was just my file we created on the fly. Paraphrase.py. Let's see what does this do. Python tool to search for paraphrases in Feist index. Most of these core functionalities come from the indexing file here. Okay. Let's just analyze the main script just to understand roughly what's going on. Names tuple, index text open. That's probably also from the indexing file. Let's see. Yep. Embed. Split open, encode load, temporary directory, token, BPE, buffered, normalization, encode time. Okay. Okay, let's see what's NLI. Language inference. Let's just skim through the script here just to get a feeling for what's going on. Load NLI data. So assume that's just a natural language inference task. We are given two sentences and trying to understand whether they're neutral, whether one implies the other or whether there is a contradiction. I think that's basically the task. Entropy, add them again. We're doing some trainings here. We're training a network, and then we're testing on several languages. We again load. This time testing on a test corpus with a test loader. Or if we're cross-lingual, then we do something here. Okay. We've gone through this one when we were playing with bash script. Let's see what is going on in this run eval script. So we are calling run eval, which does what? We construct some eval here. Target encoder, embed, xsim, blah, blah, blah. Okay, and then, okay, we're gonna step through it a bit later. Embed, we've done that. Again, as a part of the buck task. Text processing. Tokenize a line of text. Okay, these are some helper functions we've been using before. Nothing fancy there, just helper functions. Romanize and lowercase the text. So we basically just call what? If the language is not none, then we call translate. Otherwise, we just do lowering. So low cap. Let's see what's translate. Okay, it's a part of the translator package in Python. We did install this before. Okay, so indexing. This is where a lot of this core functionality is implemented to deal with VICE. That's how you pronounce that, vector codebase, vector database. Okay. Let's see what's going on the server. NLLB study group. Okay. Let's just analyze this last file, and then let's start playing with the rest of the tasks and see what these tasks do. Hopefully there's some README. Yeah, there is a README next to all of the tasks. That's gonna be very cool. We're gonna try and play a bit with them. We did play, I think, embed and buck. Those are the two we use so far. Let's just quickly skim through this. Index create. Okay. Flat L2 index is currently supported. Index flat L2, normalize. Save. Search multiple. print the confusion matrix. Load the index, read the index from here, and then index CPU to all GPUs. GPU parameter space, okay. Index text open. Not the cleanest code base in the world. Okay. Let's see. We are done there. We can now just play with the tasks. I'm just curious about how active is the repo. Let me just close down a couple of these files. Okay. How active is this repo actually? 4 years ago was the first commit. A lot of activity in June. And then the last one was in August last year. They probably have, Meta probably just has an internal version of this same repo. Should be good enough. Okay. Let me go grab some water and I'll be back in a couple minutes. Basically, then we're gonna go through some of the other tasks that are here under the tasks directory. See you in a couple of seconds, guys. Okay, that was a quick break. I'm back. Let's see. Where are we? Are you guys still here? Anyone? Okay, we went through the bug. Let's now go, let me just quickly skim here. And then we can maybe do CC matrix or something. Let's see. Hey Brian, what's up, man? Good morning. All sentence pairs which have, I didn't know, parallel. Margin criterion. The same approach can be scaled up to huge collections of monolingual text, several billions, using more advanced features of the face toolkit. Haha, nice. Please first download the bug. Optimized. All numbers are F1 scores on the test set. Okay. That's something we've done before. Let's open up the readable version. We've done this as well. I'm just skimming to see whether I missed something. Okay, we've done this, guys. Embed SH, that's good. Let's see what's CC matrix. I think I've read that paper as well before. It's just this data set, Wikipedia sentences or something. Let's see. Okay. Mining billions of high quality parallel sentences on the web. We show that margin-based bytext mining in Laser's multilingual sentence space can be applied to monolingual corpora of billions of sentences to produce high-quality aligned translation data. 32 snapshots of curated common crawl corpus totaling 69 billion unique sentences. Using one unified approach for 80 languages, we were able to mine 10.8 billion parallel sentences, out of which only 2.9 billion are aligned with English. We open source our scripts in this directory so that others may reproduce the data, evaluation, and results reported in the CC matrix paper. Okay. Pip install ccnet. And then just run the script. What's the ccnet package? Is this a actual package? See. Tools to download and clean the common crawl as introduced in our paper ccnet. Failed. Okay, let's see what's up there. CC matrix. Do we have CCNet installed already? Apparently not. Okay. To validate the quality of our mined bytexts, we train the NMT systems for most of the language pairs, and we evaluate them on TED, WMT, and WAT test set. Using our mined bytexts, okay. The same dataset was used to train M2M100, a large-scale many-to-many multilingual translation model. It outperforms English-centric multilingual models trained on data where either the source or target language is English. Follow our instructions above. Okay, so let's try and install this and see whether this crashes or not. Depends on NLLB. Okay, just a sec. I guess this will crash if we try and run this, right? Let's try and run it. Verify that CCNet fails. Okay. Let's see the issues here. Can packages installed from PyPy cannot depend on packages which are not also hosted on PyPy. Let's see. Okay. Apparently this is a dependency that we first have to install, and then we can install the CCNet package. Okay, let's now try and build this guy. Okay, this might have solved it. Okay, looking good. DL finalize. Let's put some breakpoints to here and DL. And now, what's this main? What's this guy? Func out bars. Main. And then we just call the make main. Let's exit this, exit this, exit. Wait, what was the error? Let's just repeat this again. Wrong arguments, I assume. Let's see the README. So we should just be able to call the script directly. data. Version, pairs, everything is specified there. Let's see under DL. Same here. Why is nothing working here? Got it. So you see, the README is not good. You have to actually pass an additional argument like DL or finalize to get this to work. So again, for context, for those of you who just joined, I'm trying to run one of the tasks in the laser repo that's supposed to play with CC matrix dataset. Just getting familiar with the code base. Okay, looking good. So we additionally have to pass in version DL version beta. We have a beta version ready. Let's see there. Got it. We version 1.0 beta. Downloading is using Git process in parallel. You can increase that if your network isn't maxed out. Once this is over, you'll need to run the finalize. Okay. This is a superset. It should be 641 gigabytes big and will download over 64 terabits of data to look for the byte text. So yes, it'll probably take a long time. We're not allowed to distribute a subset of common crawl. That's why we have to use this overcomplicated process to allow people to reproduce our work. So after about 1 day and running with 16 threads, I'm at about 4 gigabits. Okay, a lot of people have problems downloading this. We will not obviously now download all 600 gigabytes, but just getting familiar with what's going on here, to be honest. I'll try to clarify a bit what's going on. For legal reasons, we can't release directly the byte text. Instead, we release pointers to the byte text. Download the byte text pointers sorted by segment. Read through all those files for each segment, download it and decompress it to memory. Extract all the sentences we are interested in from this segment. Discard the segment. Split the extracted segment by language pairs. For each language pair, sort the source sentence by byte text ID. Zip the two source sentences and target sentences files together. Okay, this guy downloaded the dataset. Let's see what's his experience. Formatted like this. Never created. Got this exception. Okay. Let's just skim through this script. Let's restart this. Maybe let's add a new config here. Let me open up the launch JSON. EL. And then what was the second argument? The version. Let's first try and run something like this. Okay. Let's see whether this works now. Just curious to step through this and see what it does. Known versions. We added the beta, right? V10 beta. C matrix version. Open the remote file. Strip. And then download file, partial. And then in parallel, we just keep on downloading on the file list. And that's just from the CCNet package, okay. Okay, there is just a ton of files. All of these are, I guess, common crawl, snapshot, or something like that. DL file. Type parser, what is this? Just a class name tuple. Okay, just preparing some data structures. Open remote file. And then we do what? No, I don't want you. I want to run the previous. Okay. Parsing the line. French, Chinese. Segments. WET, CC main. Okay. Strip and split. Okay. And then we just create that. Got it. Normalized by text pointer. Assert that it starts like this. And the digest starts with SHA. The segment downloads. Get the documents. Okay, there was some error. And that means we're gonna just keep on. Aha, this one worked. Okay, let me just stop this. We don't really care about this. We don't have to go through the download of the CC matrix. Let's see the finalize function. Extract the bytetext sorted by language pair. Assumes DL has been run with the same out there and version before. We can probably just download this on Hugging Face if we really needed it. CC matrix, Hugging Face. Let's see. Okay, these are just examples. Is this somebody from Meta? Look at this burst. In the well paired homepage section of the dataset description here. That's why it's called matrix. Okay, so there are ways to download this. From Hugging Face. Why does it say 5 here? Ah, because they're the closed ones. Okay. Just skimming what's going on in the finalize function. Okay, basically the final output of this script is just we end up with 600 gigabytes or something of the CC matrix dataset. We can ignore this for now. Let's go to the next one. Let's see what's going on in this. Task, this looks just like there is only readme here. LibriVox, speech to speech. Okay, I wouldn't be surprised if this was released recently with the seamless M4T paper. Let me quickly double check that. If we open up a laser, commits, 26th of June, or we can just see the blame file. Tasks. Nah, this was added last year. Okay. So you can download it from there, the manifest files, for all language directions, by decreasing mining scores. Okay. We give the amount of aligned hours in the source and target language. Okay, this is not relevant to us. This is just speech to speech. Let's see this one. Application to cross-lingual document classification. Okay. Multilingual sentence embedding for cross-lingual document classification using the MLDoc corpus. We train a document classifier in one language, for example English, and apply it to several other languages without using any resource of that language. German, Spanish, French, Italian, Japanese, Russian, and Chinese. Please first download the mldoc corpus from here and install it in the directory mldoc. Okay. Calculate the multilingual sentence embeddings for all languages and train the classifier by calling the mldoc shell script. Let's quickly see how big that dataset is. mldoc, a corpus for multilingual document classification, citation, benchmark, Python version 0.3.0. Oh my god. Okay, this is super old. How big is the dataset? Actually, let's do the actual news stories on the Reuters corpus. Why is the documentation so confusing? Which documentation? Okay, I guess we just have to go into the source. Digging into the matrix. Here are some indices. So I assume, let's open up something like English Dev or whatnot. Okay. English test, English trained. Okay. So what do we do now with these? We have two Python files, sampling and generate documents. Okay. RCV directory of RCV1, RCV2 corpus with subdirectory structure indicated by indices. For example, index corresponds to document. Okay. And then the output file name. Output file name, path to indices file. Where do we get the indices file? Is that the, I guess those are these ones. Okay. You open up the indices file. We go through the indices and then we join the RCV directory with the subcorpus. What subcorpus exactly? We get that from the line, okay? And then we join with the file name. And then we open up that thing. Topics. I mean, sometimes I think it's better not to release stuff than to release it like this. Criminal. Check data sufficiency. For those of you who just came, we're trying to run the mldoc task in laser directory. in laser repo, which is basically the encoders for bytext mining for machine translation datasets. Generate samples. Let's see what this generate samples. Okay, let's see. What do we actually call here? There is a threshold ratio of expected number of examples if uniform prior. Directory of RCV2 stories to sample from. Output. Test staff. Train. Class prior labels. If this is none or this is none, need to provide directory of our RCV2 data. And then we go through the input directory and we call generate samples, which then does something. So apparently there is no mention whatsoever of where that data set is. Non-commercial license, of course. The worse it is, the less permissive it is. Evaluate variance through bootstrapping. So RC stands for Reuters corpus. Both RCV1 and RCV2 requires a NIST agreement. So we created indices to the sample documents included in the benchmark dataset. Subcorpus name and document name. Okay, to use these indices to run the exact same, the following script can be used to generate the actual documents and their labels. Okay, so I think I understand. So it's basically, this helps you form, you don't have to have, no, you actually have to have RCV dataset downloaded. They just create pointers to the data samples from the dataset that they've used. And then we have to go here probably to download this thing. Yeah, RCV1, getting the corpus. What's the size? Mega, giga, GB. Okay. It requires about 2.5 gigabytes for storage of the uncompressed files. Okay. RCV2. The web download contains over 487,000 Reuters news stories in 13 languages. The stories are not parallel, but are written by local reporters in each language. The stories are contemporaneous with RCV1, but some languages do not. Okay. Okay, so this is, oh my god, so you have to wait like up to 7 business days for a response to get access to the data, to get the corpus. You have to send a scanned PDF file, complete and keep the individual agreement form on file at your organization, and then if they allow you, you can then download in like 7 days or something. Yeah, this is not gonna happen, guys. This ML doc is not gonna happen as well. I mean, it's fun. It's fun to get this understanding of how this landscape looks like. ML doc and CC matrix are both fairly broken. Let's see the similarity. I'm just actually curious. Let's just skim through and see what it does. what the scripts do, even though we would not run it. Okay. Extract MLDoc. If the file doesn't exist, and we grab the first field, training the MLDoc classifier. By calling the sentence classifier script. And then we display the accuracy matrix. Okay, and what about MLDoc py? Okay, that guy is called here. Probably to process the data set. Split lines, encode, join embed, etc., etc. Okay. What's up with this? I think we might be able to skim through most of these tasks by the end of this stream in 30-ish minutes. And then I'm gonna create a plan. What's the best next steps? How do we start with the project? This is just still the exploratory phase. I'm just trying to understand better the landscape. Shows how to embed an n-way parallel corpus from WMT 2012 and how to calculate the similarity search error rate for each language pair. The n-way should not contain duplicates. Okay, simply run this to download the data to calculate the sentence embeddings and the similarity score. You should get the following similarity search errors. Okay. Let's double check how this looks like. So we download the data. We extract it, remove the tar archives, and then we call the similarity search with some languages. Okay, those are all of the scripts we saw before in the source directory. So we are calling the similarity search.py. Okay. This might be fun to run, but we don't have to do it now. Got it. Search multiple, that's the main logic there. And then we just grab the errors and we print them. Okay. Let's continue. That was a similarity task, Wiki matrix. I think this is somewhat related to CC matrix. It's just that for Wiki matrix, they use Wikipedia as the source when mining as opposed to using common crawl CC. Okay, let's kind of skim through this. The goal of this project is to mine for parallel sentences in the textual content of Wikipedia for all possible languages. Mining 135 parallel sentences in 135 million in 1620 language pairs. This table shows the results. Okay, that's the PDF file. Let's open it up. How do you open up a PDF file from a terminal in Ubuntu? Open PDF in Ubuntu from terminal. Maybe just open. Okay, fair enough. Size of mine sentences in thousands for each language pair. So if we see something, I guess this will be English somewhere. Do we have even English here? English is here. I guess that this line should be English, maybe. Yeah. Yes. That's correct, because it's the darkest line. Okay. The mine byte texts are stored on AWS and can be downloaded with the following command. Replace EN French with the ISO codes of the desired language pair. Must be in alphabetical order. Okay. $65 gigabytes there. Let's see what are some smaller languages. They said this is in what? The list of available byte text and their sizes. What's the size? What's the size unit? Probably gigabytes. This is 24,000 megabytes. So this is in megabytes. 24 and 12, 36. No, can't be. Let's take some small one and just download it for fun's sake. Like this one. Or no, let's just grab something, some language that I speak. English, Spanish, or German. Chinese. Is that Croatian HR? Let me just double check that. If we open up the PDF here, what languages are supported? So there is even Bosnian. Okay, Bosnian, Croatian HR. Is there Serbian, Serbo-Croatian, SH? Okay, let me open up. Let's see whether there is English SH. Okay, let's grab this one. Let's just navigate here. We are already, no. Let's go to Wiki Matrix. Let's just grab this file. And let's just change these infixes so that we have English and then Serbo-Croatian. It's a small file, so only 17 megabytes, and then we can use that to figure out here 17 megabytes. Why? How does that map to 224? Huh. Okay. Let's open up that file. Let's see the approach. Let me first to extract from the TSV files. Okay, there is a utility function to do the extractions. I'm curious to learn which models are they using. 2 and 3. Margin-based parallel corpus mining. Okay, those are some older papers from 2018. Okay. We do not use the inter-language links provided by Wikipedia, but search over all Wikipedia articles of each language. We approach the computational challenge to mine in almost 600 million sentences by using fast indexing and similarity search with FICE. Prior to mining, let me see how active that repo is. Last week. They're certainly using it a lot inside of Meta. Okay. Okay. The mine data is distributed under the Creative Commons Attribution Share Alike. Okay, that's cool. That's not, we can use this for commercial purposes. That's cool. That might be interesting to see, just to understand how much data you need for a language pair. Okay, Wiki matrix blue. Let's open up that one. Sizes and blue. What? Tasks, Wiki matrix, blue, PDF. Why is this not working? Let's just copy this path. Open. Paste this guy. Okay, here it is. So, of course, English is always going to be good. Let's see English, Serbo-Croatian. That's not a language. You have Serbian and Croatian now. SH, Bosnian and English 21. HR 24. And then I guess Serbian is SR 22. Okay. $4,226 and Croatian HR even less size. Okay, interesting. Okay. Let's try and run this and just see how. Let's just see how the TSV I downloaded looks like. So let me open up this. Let me rename this because we won't be running this. Let me rename this to Wiki matrix. And let's pass in this arguments. So this is the extraction script. So we have TSV. That's gonna be Wiki matrix sh, and then comma, and then bytext. Wiki matrix English sh. That's probably going to be the output of the script. Source language is English. Target language is, I guess, sh. Maybe worth trying the Serbian to see what's the difference. And then threshold is going to be 104. Okay, let's run this guy. So let's open up the extract file. Okay, and let's run it. Let's just set the right config. So we want to Wiki matrix, and then let's run it. encoding UTF-8, TSV, bytext, text file after sentence splitting, source language, target language, threshold or margin score, maximal number of sentences set to what is this, like 1 billion, number of words, maximum number of total words in the source and in the target language. And then we start processing. We open up the file as a textual file with UTF-8. We open up this as this is where we're going to be writing into source and target. And I guess we will create a parallel corpus here. So while MB sentences, while we are smaller than maximum number, we read a line if it exists. Okay. Whoops, what happened there? No such file found. En